On this episode of StarTalk, it is StarTalk Live at Pioneer Works in Brooklyn. My comedic co-host is Paul Mecurio, and our special guest is cosmologist Janna Levin. And we talk about my latest book, co-written with our longtime senior producer of StarTalk, Lindsay Walker. And after that, we talk about Einstein's greatest blunder, we talk about Edwin Hubble the man, not the telescope, and a lot more coming up on StarTalk. First up, the humor part comes from a professional stand-up comedian who's a participant in practically every episode that we post. Tonight, we have our friend and one of my favorite comics around, Paul Mecurio. Paul, come on up. Where are you? Good. Paul, you got a podcast of your own.
I do.
And it was creatively called what?
It's called, see, he's insulting the title of my podcast already. Okay. Inside Out with Paul Mecurio.
Inside Out with Paul Mecurio.
Yes.
Okay. All right. I've been a guest on his podcast.
And we had a great time at the planetarium.
Yes, we did.
Yeah.
Yes. Yeah.
And then a few drinks, and we broke a couple of things. But
that's right.
No.
So thanks for coming on.
Thank you for having me.
This event.
Is a live thing. This is an amazing space. I've never been here. This turnout's amazing. I'm really excited, and then we're all going to go swimming after this. Just right.
Well, in the East River here, you're saying.
Okay.
Next up, we all know and love her as Janna. She is Professor Janna Levin. Janna, come on up. Janna Levin. Does she need an introduction in this space? I don't think so, but we'll do so anyway. So you're Tao Professor. Tao Professor of Physics and Astronomy at Barnard College of Columbia University.
Where we first met.
It is. And you're Director of Science here at Pioneer Works. Brooklyn in the house. Yes. Editor-in-Chief of the Pioneer Works podcast. Author of How the Universe Got Its Spots. One of my favorites. Black Hole Survival Guide.
It doesn't end well, just, you know,
yeah,
spoiler alert.
You don't survive that, okay? And also one of my favorites, The Black Hole Blues and Other Songs from Outer Space. That's how you want me to say it.
All the time. I want you to say it all the time.
The Black Hole Blues. And so, in fact, tonight, we are going to focus on the fourth section of the book, which is really where the title of the book takes shape, To Infinity and Beyond. Places where our bodies can't go, but our minds can. So, let's begin here right now in Brooklyn. Let's do it. All right. Okay.
I love being a guest on this stage, by the way.
Oh, yeah. No,
I love that you're the host. This is so fun for me.
I got you. So you can just chill.
Yeah.
And we have questions for you for us to understand. So, in the book, it's about upheavals in our understanding of how the world works and how we reacted to that. Were we elegant and graceful, or do we get dragged into the future kicking and screaming? Not all stories in the history of science have smooth, sort of journalistic, burn the midnight oil and say eureka at the end. So let's detail some of the weirdest, wackiest ideas in the universe. And you got to start with who? Einstein.
That was just a good guess.
Yeah, so his theory, special and general theory of relativity, and you're an expert on that, right?
Oh, absolutely.
Yeah, just checking. So tell us about Einstein's biggest blunder. And we talk about this in the book just because this is some of the fits and starts that we go through to understand the universe. So what's going on with this?
I love this about him because here he is dreaming these dreams that defy everything everyone else took for granted, but then he has a moment of like resistance, and it's emotional resistance. He wants to believe the universe is permanent, that it didn't have a beginning and it won't have an end, and that it's like static. He wants that. That's an emotional response. And even in his own mathematical theory, he's surprised when other people study it and tell him it predicts a beginning of the universe and an end to the universe.
His own theories
His own
predicted
theory.
it, and he couldn't handle it.
He couldn't handle
He
it.
couldn't handle the
Well, did
truth.
you ever stop?
Couldn't handle the
but
truth.
maybe he just was exhausted at that point. He's like, I've done all this. I know some of it's wrong, but I need a year off. I need some drinks. Like maybe that was the issue for the guy.
Well, crazily enough, the guy almost can't be wrong even when he tries. So he introduces what he calls the cosmological constant, which is just a term that's mathematically consistent with the general theory of relativity, but he declined initially to include it because it made no sense. It came out of nowhere. He couldn't explain it. He couldn't justify it. But what it allowed him to do mathematically was precariously balance the universe so that it was static. But it was very, very unstably so. And when he realized that, he was like...
Right, so just so people are on the same page, I know you guys are scientifically literate here, but just to make sure, you can balance a marble at the top of a hill, and that's a point of equilibrium, but it's not stable. Because any gust of wind will send it one way or the other.
Yes, and in this case, the gust of wind would send the universe contracting or expanding.
Whereas if the marble were at the bottom of a hill, it's also a point of equilibrium, but it's stable because you can displace it and it'll always return to that spot.
And that's what he was hoping for. He was hoping that if you tried to make the universe expand or contract, not be static and permanent, that it would actually prefer to stabilize. But it doesn't. It's actually very, very hard to stabilize the universe. And as we know today, the universe is in fact expanding.
So Einstein was an idiot, you're saying? Yeah.
But what was it? I mean, there's a quote in the book where you say, with the notion of a static universe firmly anchored in its philosophical substrate, Einstein developed his general theory of relativity, and it embodies his assumption of a stagnant universe, even though his own equations reveal the unsettling truth. So he must have known. Why couldn't he get his head around that reality?
Well, I think nobody really knows. I don't know if there was really a sense of investigating with him why he was so resistant to the predictions of his own theory.
Can it be really his fault? Who would have been the first to say the universe has a beginning? I mean, religion said it, but scientifically, there's no reference frame to even have that thought.
No, it's really stunning. It's the first time there's a scientific concept of a beginning, a Big Bang, beginning
Listen,
of the universe.
I think it's clear the guy was closed off emotionally. And
you got the analysis. So tell me about Lemaitre.
They looked at Einstein's equations, which he wrote down after lots of fits and starts. He used to say things like, if you think you have troubles in mathematics, mine are greater. It's amazing he kind of made it into the canon, really, that he wasn't just sort of forgotten and excluded.
Yeah.
But he's studying this and he says, you know, if I imagine a universe where everything is kind of smooth and uniform in the whole universe, and I ask, how does space and time respond to a universe full of stuff, as long as it's kind of smooth? You know, it's a very simple system, but not that far off from actually what we observe. But he realized that in response to a universe full of stuff, it wants to either expand or contract.
All right, so...
It doesn't want to just sit there.
So did he finally agree to this?
Einstein, yeah. He agrees after Hubble in the 20s.
Hubble the human being.
Hubble the human being, after whom the satellite is named.
Yes.
Is up
It's not
there.
just a satellite.
It's pretty.
It's a telescope satellite.
It's a telescope
Okay.
satellite. It is.
Thank you.
An amazing phenomenon. Hubble looks out at a smudge on the sky, and he's not sure what it is, and he's trying to figure out, is it a nova, which would be a nearby object that's very bright, or is it a distant galaxy, and much brighter and much more distant? And there's an actual plate, photographic plate that he took where he crosses out NOV, and he writes VAR with an exclamation point, a variable star. And it makes him realize, because of his understanding of variable stars, that it's a bright object far away.
Very far away.
And that's based on Leavitt, right?
Henrietta
Leavitt's law?
Henrietta
Henrietta
Leavitt's
Leavitt,
work, yeah.
Classified this variety of variable star that turned out to be crucial to understanding the distances to objects. So
Leave it to a woman. There you go.
yeah.
You made it happen. Good job.
Great, unbelievable story, actually, about Henrietta Leavitt and all that whole crew of female astronomers around the turn of the previous century. They were called Pickering's Harem because Charles Pickering, who was the director of Harvard's observatory, hired them for 25 cents on the dollar after he fired all of the male astronomers because they weren't doing a good job. And he said, my Scotch maid could do a better job, and he hired her, which was Wilhelmina Fleming, and she hired all these women, and they became this cluster of phenomenal observational astronomers. Unsung heroes, they died in poverty, penurious.
And
but
there's a book
Hubble,
highlighting their careers.
Davis Sobel.
Davis Sobel, that's right. Called the Glass Ceiling. No. The
Glass Universe.
The Glass Universe.
We had David here to talk about that book. Yeah, and it's an incredible story, but Hubble knew about that work, which is remarkable. If he did not know about these unknown women and their work that they were doing at the Harvard Observatory, he would not have understood that he was not looking, if you just imagine a light bulb up close, that he wasn't looking at something up close, but he was looking at something much, much brighter that was very far away.
And so we are now in the centennial decade of Hubble's major discoveries, as well as the centennial decade
we are,
of
exactly,
the discovery
it was 1922.
Exactly, of most of the discoveries of quantum physics. So that was a watershed decade right there, the 1920s. So fast forward to 1998, and we discover a value for Einstein's constant.
That's insane. It's insane. So this is what I meant. He can't even make a mistake. So he introduces this thing to try to make the universe not expand. Hubble comes along and says, I saw this galaxy, it's really far away, and then I saw a bunch of them, and they're all moving away from us. The universe is expanding.
The whole universe is expanding.
The whole universe is expanding. We're not at the center. We're just we're also moving away from everything else. The whole thing's expanding.
And that calls into question the age of the universe, and if any of those numbers are right, and all of that.
And we find out that not only is the universe expanding, it's accelerating by the power of this term in Einstein's equation. So in fact, the term does exist.
Crazy.
So even when Einstein was wrong, he was right.
He was right. Exactly. So everyone's like, Einstein,
that's badass.
Get rid of that constant. It's a big blunder. And then in 1998, long after Einstein passed, they realized, oh, actually, the only thing we can think of, not just to make the universe expand, but to make it expand faster and faster to accelerate, is the cosmological constant, his biggest blunder.
Okay,
so it turns out to be right.
So if we're expanding, that means yesterday we were smaller than today, and the day before, smaller than that.
And I'm shrinking then.
And if you go back in time, there's got to be a point where the whole universe is occupying one spot. It had a beginning. Oh my God.
That's Lemaitre coming in, which is actually very interesting. I wonder why Einstein was more resistant to the idea of an expanding universe than a Catholic who had to confront the idea that the universe was ancient and had a beginning.
Right.
I mean, I think that's
the beginning part
amazing.
was easy because Genesis is a
beginning.
Right,
but not 6,000 years ago.
Yeah.
14 billion years ago.
Yeah, billions of years ago. So if it had a beginning and it's expanding, does the universe have an edge? And by the way, these questions, is that any different from sitting here on Earth and saying, how do I get to the moon? I don't know. Pose the question. And you heard in this exchange that the answers to the theories had to wait for experiments to join the conversation. Mm-hmm. You can't just sit in an armchair and claim you fully understand the universe. So, does the universe have an edge?
Are you asking Paul or me?
Oh, Paul, does the universe have an edge?
I think it does. I've been to the edge, and
no,
it's the Hamptons.
Some people have edges.
So in the context of this, in the book, you talk about the human ego, right? And there's an interesting concept there, which really sort of surprised me. And what you say is that given the battles that raged, et cetera, you say, we know the universe is expanding, blah, blah, blah. The ultimate defining barrier between
blah,
space
blah, blah.
and not space. However, there's a lot of stuff. By the way, the book needs more pictures. It's like, oh, look, a spaceship, woohoo. No, it's a great book to fall asleep. And I think I'm never coming back on this show again. So No, so in all seriousness, this is a quote from the book. We know the universe is expanding, and that expanded from a single point. Furthermore, everything in the universe must obey a speed limit. Reason would dictate that the universe must therefore have an edge. However reasonable though that might sound, it arises from a faulty premise, driven in part by the human ego. And I was fascinated to know what you meant by that, driven in part by the human ego.
Well, an ego, just, are you in the center of everything? The authentic center? If you learn you're not in the center, can you deal with that? Can you handle?
You can.
Because, no, just think about it. And we detail this once again in our ascent from Earth into the solar system. You say to yourself, we're in the center. By the way, we made calendars not knowing, calendars we still use today, not knowing Earth went around the sun.
Yes, but they're adorable. They have puppies on them.
No, they're all good. So you can deduce a whole lot about the world without telescopes, but one of the things you cannot deduce is that Earth is going around the sun. That's messed up. Okay, that meant we went thousands of years thinking we're in the center of the known universe, fully feeding our ego.
But why wouldn't you? And when there's no proof of anything else, in all seriousness, why? What other premise would you?
You're being too hard on, pre-BCE civilizations.
Neil. What are issues that you have inside of you?
No, what I'm saying is,
you need a hug.
The whole universe.
Come here. You need a hug.
The whole universe is masquerading as a system centered on us. So we're not given reason to question it because it feeds our ego. When something feeds your ego, you say, yeah, it's probably true. Not asking, well, maybe it's not true. Because maybe it's not true could have the result that you're not in the center.
But think about the ego you have to have as these great astronomers and scientists to say, I'm going to go and look into something that no one else has done and then stand by it and believe in it before anyone else does. So
that's not ego, that's curiosity.
No, but you've got to have an ego to stand by something, I think.
No, yeah, then you're stubborn.
I'll fight you right now.
Yeah, if you have an idea and you stick by it, regardless of the data, go home. That's not what science is about.
Well, that's what Einstein did.
Which is why we discuss not having debates over science, because no scientist worth their salt wants to come in with a notion and be unyielding or unwilling to accept a new idea or adopt it when it's clearly right.
So two scientists in an argument, there's a different contract between them than there is between two people debating on a stage. So that contract is, either I'm right and you're wrong and I'm wrong, or we're both wrong. So we'll argue until we get to the edges of what our data can show, and then we say, I think we need better data. Let's go have a beer, right? Said no one ever at the end of a political debate. But
the idea of the infinite universe kind of fell into that category, because when Einstein was first writing things down, he was just doing the first pass, so to speak, and he has a famous quote where he assumed the universe was infinite, but he also assumed it was static, and he said something to the effect, only two things are infinite: the universe and human stupidity.
Yeah, best quote ever.
And then he added, and I'm not so sure about the universe.
That's right. I forgot about that.
Isn't it a matter of the observable edge versus?
There's an observable edge, for sure. So we can only see as far as the light has had a chance to get to us.
But it's not a physical edge of the universe.
But it's not a physical edge.
So you can't drive through the universe and say, the universe ends here.
Well, we don't think so, but we're not actually 100% sure. We don't believe that there's an edge any more than there's an edge to the Earth.
To the surface of the Earth.
There's not a sign, welcome to the edge of the universe.
Right. So, if I travel from New York City and I go in a straight line, I don't fall off the edge of the Earth. Right? There's no edge. I make my way all the way around and I come back to New York City again, and that's actually a really valid model for a universe that is finite, not infinite, in which you go into a spaceship, you leave the Earth, you travel in a straight line, you go out of the galaxy, you don't deviate, and you find yourself approaching the Milky Way again with the Earth in front of you. And you've never fallen off the edge of the universe. It's completely contiguous, but it is finite.
So I have to repeat a quote from one of my earlier books. The universe is under no obligation to make sense to you. Tell me about the intersection of time and space, which feels so unintuitive, but actually we exist this way. The example I give is if I say, oh, Janna, I'll meet you tomorrow at 10 o'clock. What's your next question?
Where?
Where? I gave you a time, but I didn't give you a space.
I'd say, are you bringing wine?
So then I say, Paul, I'll meet you tomorrow at Starbucks. Okay? We know which Starbucks, and then you'll have to say?
What time?
What time? So we know this intuitively. So then Einstein stitches them together. Why do people lose their mind?
Well, it's amazing because a lot of things he did were actually really simple and intuitive, but he pushes it much farther, where many people would start to get flummoxed and give it up and just be happy to meet at Starbucks with a bottle of wine. That doesn't really make any sense, but okay, Paul. And but
always go to one with a bathroom. You can do whatever you want.
So he starts to think, well, I can draw up and down, north and south, east and west. Why don't I just also draw a dimension called time, and then we can just agree on where we are in space and time. And then he kind of pushes that further and further and further until he starts to say, oh, it's a space-time. And it's surely
That's one phrase.
One phrase.
Space-time.
I don't like editors out there. I don't like when you put a dash in there. It's space-time. And
no, paired words have to evolve.
Yeah.
And then they eventually lose their hyphen, okay? But like percent used to be 2 words, then it was hyphenated.
Yeah, in French
now it's
it
1
is.
word.
Percent.
But why don't you like the hyphen?
Because it separates space and time in a way that Einstein was trying to transcend.
And in this book, we did not use a hyphen. We have editors that followed suit here.
Nice.
So we got
I love it.
National Geographic editors. That's a National Geographic book. Okay, so what that means is that if time is a coordinate, it can stretch or shrink. So you have different rates of time. Christopher Nolan did that in the movie Interstellar.
Yeah, which was by our friend, the original treatment was by Kip Thorne.
Yes.
Who's going to probably
physicist.
come up in conversation
Yeah,
today.
he's your counterpart at Caltech.
Yeah.
Yes.
Well, that's a compliment. Thank
Okay,
you.
no, yeah,
I'll
totally.
take it.
Totally.
No, Kip was one of the most gracious, elder statesmen of science when I first met him.
And they made him an executive
generous
producer
people.
of Interstellar. So that meant you knew the science had some backbone.
And then he won a Nobel Prize. Really weird order of things.
Yes, yes.
Chronologically weird order of things.
Behind that Nobel Prize, the real person was Matthew McConaughey, gave him all the information. He's a brilliant, handsome
The person
man.
behind the Nobel Prize, yes.
He'd hang out in his trailer, and Matthew would be like, no, man, that's not how you do it.
Wait. So you have, if you're nearer a significant source of gravity, your time frame slows down relative to other people.
Yeah,
That's freaky.
It's very freaky, but in Einstein's language, it's no more freaky than the fact that my left and my right are rotated relative to your left and your right. In Einstein's language, you can rotate space and time differently than somebody else's notion of space and time.
In a 4-dimensional coordinate space.
Yeah, in a 4-dimensional space.
Yeah, that's real easy to grab there, yeah.
That, when you near the black hole, it's as though you're rotating in space-time, just like you could rotate left and right relative to somebody far away. And just as I won't be like, my left is an absolute notion, obviously I'm rotated and it's relative to your left.
If I face you, that's my right.
Exactly,
yes,
100% rotation. And he says as you near the black hole, you have 100% rotation of your space, if you're far from the black hole,
with
my time that's near the black hole. It's just like my left being 100% rotated
that's
into your right.
That's freaky stuff.
Yeah.
All right, so what about wormholes and whether we can use that for time travel?
That's Kip Thorne. Or maybe it's Matthew McConaughey. I'm not really sure. I don't know.
Can we do this without a DeLorean?
Yeah.
Which is now, by the way, on Broadway. This Back to the Future,
way.
the musical, now on Broadway. Yes.
You really said that as though you were promoting it.
He's got a piece of the
Well, just a quick point there to your space-time fact. I just want to slip this in because we have it in the book. If you go in a time machine and say, I want to go back 3 days. So you go in and then you step out and it's 3 days earlier. you would be in the vacuum of empty space because Earth is in a different place.
But why is it empty? It's still Earth. Why are you in a vacuum of
Because Earth is in orbit around
and the
sun.
atmosphere went with it.
Earth isn't, you just went back in time, but Earth was in an orbit. You go 3 days back in time, you didn't say, keep me on Earth and do that.
And the whole solar system moved.
The whole solar, so if you actually want to go back in time and show up on this stage, you have to go back in time and in space so that the Earth is where you need it to be at that time. So the space-time thing is real if you want a time machine your way around the galaxy. Now they got around this in Back to the Future because he jumps into the car, quickly types in a thing, and he goes back exactly 30 years.
So he's in the same orbit.
The
Same point
Earth
in the orbit.
would have been in the same spot in its orbit.
But did he also calculate for the fact that the whole solar system is rotating around the center of the galaxy?
For 30 years, no. He left that one out. You got to give him a hall
it's not
pass.
very much.
They got one of those
It's not
right.
What is
very much.
magical about 30 years in that scenario?
It's just
Because it goes, it goes
any
from
years.
1980, no. In that scenario, it goes from 1985, the year of the film, to 1955, which is a very fun setting to put a movie in, okay? Because teenagers are coming of age, so...
Chuck Berry's music gets stolen. It's a great time.
Oh, Chuck Berry's music, do you know, who has not seen Back to the Future? Okay, a hand went up. Security, could you take this person out? No, just a quick point about Chuck Berry's music. Marvin Berry, the brother or the cousin, was he the cousin? Okay, hears Marty play Chuck Berry, but that song isn't written yet. He holds up the phone for Chuck Berry to hear Marty play this Johnny B. Good song. Was it Johnny B. Good?
Yeah, exactly.
To play it, and he says, Chuck, this is the sound you've been looking for. Okay. So holding aside that it credits a white person for giving music to a black performer, holding that aside.
Which is exactly what I was going to
You're
say.
holding a lot aside. That's a tsunami.
Holding that aside, there's something called a Jinn particle. Do you know about Jinn particles? These are things that are neither created nor destroyed. And they involve the time continuum. It's a loop in time where that song in that movie was never written. It only existed to be handed into a time loop. And we call it Jinn particles because you can hand a person something that you then give to me later in time, and that was never created nor was destroyed.
Oh, but when she hands you that later in time, you can't say that it wasn't invented previously.
No, because I go back in time and give it to her. This is the time travel enables Jinn particles to exist.
So this is along the lines in the book where you talk about sort of you go back in time with a spaceship, and just before you're about to leave, the day before you blow up the spaceship, right? And then you've got...
I wouldn't do that, but yeah, go on. Yeah.
Well, it's in your book, sir.
Yeah. No, it's a scenario. Go on.
And so where you're talking about parallel universe, right? And sort of how things break off.
Yes.
Right?
Yeah. That's right. So can we travel backwards in time authentically?
Well, this is all interesting related to it because you're assuming that the person who traveled back in time could make a choice that was inconsistent with the physical universe
with what
in which
actually
they
had
live.
happened, yeah.
Right, and Neil, you saying, well, I wouldn't do that, is actually kind of close to the bone because it's really the presumption that we have a free will that could do something that defies the laws of physics. So you can completely go back in time as long as you don't exercise any free will that deviates from the consistency of that universe.
That's what you call in the book the butterfly effect, right? Like you go back in time,
right,
and then you start this sort of ripple, right? But so
that could then change all future events.
Right.
But you don't have the option to do that.
Even if it prevents the birth of you, who then went back in time.
Wait, let's back up.
To prevent that. Wait. So my favorite example of this is I see a friend of mine walking down a corridor, and they slip on a banana peel, okay? And they get hurt. I don't want my friend to get hurt. So I pull out a new texting service that uses particles that travel backwards in time, tachyons. And so I send a text backwards through time so that my friend receives the text before he steps on the banana peel, and therefore they don't fall. So I do that.
But what if he has his phone on airplane mode and he doesn't get the text?
Well, let's find out. So I send the text back. My person feels the vibrate, picks it up, looks at it, and it says, watch out for the banana peel. But while they're looking at it, they don't see the banana peel, and they slip on it. So the very fact that I sent the message back in time is what caused the slippage on the banana peel. And so that's the temporal event laws of physics that you're referencing.
Yeah, strictly speaking, the laws of physics, we know that general relativity has universes, hypothetical, not ones that we've yet observed, in which you can do exactly what you just described, go back in time. But there is no law of physics that we know of that allows you to do so in a way that is inconsistent.
That prevents you from existing.
With the exact path that you are
So
on.
the idea of being able to alter my future by going back in time is...
It's very 12 Monkeys. Yeah.
Ooh.
12 Monkeys?
Yeah, you don't know. You're giving people
I
a hard
missed that
time
one.
about.
I know.
How did you miss 12
I
Monkeys?
remember I saw it, but I
Somewhere in
forgot
between
it.
Now and Back to the Future.
Yeah, I forgot it.
But
Sorry.
could that be wrong?
Could what be
Yes,
wrong?
it
Could
could
that
be-
be wrong, right? So there was a refinement of
Could it
the
be
process to
wrong?
figure out the age of the universe, right? Some that started at 3 billion and then 5.5 billion or whatever. And to this day, right? There could be some new science that gets discovered that
Yes.
makes this inaccurate, right?
Yes.
What we believe now.
Or some time science.
So there's nothing
that
absolute.
remains to be discovered.
There's nothing absolute.
Never is there.
Other than Neil's handsomeness, there is nothing absolute.
And even Kip Thorne, who's come up a couple of times, who looked at this concept of wormholes. Wormholes were originally proposed kind of like, you know, the battery tunnel or something. It was a shortcut from one place to another. You know, you go under the East River and you connect Manhattan and Brooklyn. Not that weird, right, to find a shortcut to get from one place to another. But what Kip Thorne did, which was exceptional, is he figured out a way to make that shortcut also traverse through time, so that you weren't just traveling from a shortcut from one space to another space, so you didn't have to go the long way around, but you could actually go earlier in time.
Oh.
And they were time
a
travel
time
wormholes. They were time wormholes. But I think if I remember correctly, you could not go back earlier than the
when
time.
you were born.
Oh, no, than the time at which the wormhole was created.
Oh.
The whether you could go, so none of these things forbid the possibility that you could go back in time before you were born, kill your grandfather, the grandfather's paradox, before he had your mother, and then you were never born.
You don't have to kill him. You just have to prevent them from meeting.
Well,
Yeah.
this is
It's so Terminator.
Or slipping on a banana peel.
Yeah,
one of the two.
or have them have sex 10 minutes later than they did.
Oh, yeah.
A different
Right.
person
Okay,
gets
now
born.
I'm throwing up in my mouth a little
Okay,
bit.
no, sorry. Okay.
It's actually very much like your banana peel story, because a lot of people think that the resolution is that if you went back in time and tried to kill your grandfather, you might just wound him. And then he's so mentally disturbed that when he has your mother, she's tormented and traumatized, and you're so psychotic that you go back in time to try to kill him.
What happened in both of your childhoods? So what you're saying is that the wormhole is like a doorway that has to exist at that point in time, or before that point in time, that you want to travel back to, right?
It was just Kip Thorne's idea for a way to make that happen without altering the entire universe, a way of doing it locally, so that you don't have to think of an entire universe that violates, you know, time moving forward.
Okay,
but
so
you could do it right here.
We're
You
still
could make
constructing
it like a machine.
the rules of time travel, is what this sounds like.
Yeah.
Yeah, okay. Yeah. But traveling to the future, that's no problem.
Oh yeah, I can definitely, obviously we're all traveling to the future. We are in the future from where we were.
At a rate of 1 second per second.
Exactly, and none of us can stop it. It's really weird. I can stand still in space, more or less, but I can't stand still in time. And,
So right now, this is the future. It's not the present.
It's the present, but a second ago when we stood on stage is the past. We have traveled.
We are prisoners
We have
of the
traveled.
present, forever transitioning between our inaccessible past and our unknowable future.
That's what happens when you drop acid before a show.
No. All right, so
Wait. Can we just go back to that for 1 second?
back to the future?
There can't
Okay.
be there is a present
Yes.
right now,
Yes.
and there is no future.
I can't say that. So there's questions like, is this like a hill where the future exists already and we're just traveling towards it, but it already is there, like a physical hill? Or is it kind of unraveling in front of us instantaneously. That's not a
we don't know the answer.
Is there a
to.
predetermined destiny that's scientifically based?
That's part of that question. Well, you're not going to stop the expansion of the universe. I would call that a scientific future.
I would say that if it wasn't for the pretty big curveball of quantum mechanics, that the answer scientifically would have been, if not for that curveball that, as you pointed out, happened right at this time a century ago, absolutely predetermined from the second the universe was created. Us sitting here would have been exactly as it had to be. Quantum mechanics is a curveball, but it's not a curveball that really saves us a lot.
So what is deja vu? In all seriousness, like, we all had it, right? Like, we're in a moment where we go, I remember feeling this thing, or it just happened to me the other day, right? So is that somehow tied to this? Could one argue that it's tied to all of this?
Now, George Carlin argued that he has vujade, which is where he goes into a place and he's certain he's never been there before. Okay? So that's me. That's right.
So I mean, to me, this feels in some way, I mean, you're nodding your
Are
head.
you having deja vu right now?
I am. I feel like I was in a place before where Neil was telling that joke.
So we got to bring this to a close here.
Oh, can we talk about the human ego? No, free will. You talk about free will in the book in the context of this.
Yeah, we do. That's a whole.
Yeah, but it's a really fascinating concept.
Well, then they have to buy the book.
Well, I'm helping you sell the book, buddy. Why don't you talk to them? I can't do everything, Neil. I can't write the book. He didn't write the book. Lindsay wrote the book. And
So Janet, take us out. Can you imagine a future of actual wormholes that we create, or warp drives, something to help us move across the galaxy with something other than chemical fuel rockets?
Yeah, I actually can. Now, but it's really, so just like you build a bridge, you know, under the water between Manhattan and Brooklyn, you have to think about
a tunnel under the water.
To me, they're all bridges.
wow, you just lost a lot of credibility with me. I'm not being a jerk, but I know the difference between a bridge and a tunnel.
Okay.
I'm the smartest one on this stage right now, everybody.
Okay.
Good night.
No.
So you know about the spherical cow? This is kind of like all physicists think anything that connects one thing to another is a bridge. Anything that connects one thing to another is a bridge. And you think about how much energy, money it would cost, and how to do it, like what materials you would need. So very similarly, when Kip Thorne and people like that were talking about wormholes in space-time, they were like, what kind of fuel would I need? And they just made it up. I know it has to have certain properties, it has to repel, it has to keep this open. And they, you know, made the wormhole great, but then they looked at the fuel and they were like, we've never seen anything like this in the observable universe. So nobody knows of a fuel or an energy source that can do what the wormhole can do.
But if we had that fuel, we could
do
build
it. Absolutely.
wormholes.
Well, that was my. How does one make a wormhole? And it's very difficult to get contractors to do work. How long does it take to get someone before they give you an estimate and then actually start on the
You're asking me
wormhole?
about the time.
Wait. Plus, wormholes, as I understand it, are unstable. And if you go through a wormhole, they could collapse on you in a moment's notice.
Right. That was a real problem, is it kept pinching shut and separating the two space-times completely. And so you couldn't make it through without being crushed to death or annihilated. But doing that, you can make them stable again if you make up a form of energy that we have never seen in the universe. But it doesn't mean we never will see. I mean, Einstein's greatest blunder, you know, in 1916 was general relativity. When did he write it down? Must have been that same year.
1917.
1917, and it was 19.
It's in
I'm
the book.
believing you.
Okay, good.
You wrote the book.
Okay, good.
No, I don't care. Time. Shut up.
Good.
Wait.
That was good. No, I was impressed.
I made notes.
You didn't even have to look at your
I
notes.
made notes. Hang on a second.
You just looked at me.
You talk about the difference between bridges and tunnel. I'll be right back here, right?
Paul, we're proud of you. It's real good.
Let's talk about Seifert variables.
No. So watch. So
The universe finds a way, is all I'm saying.
okay, and it's not any different from going back 200 years ago and saying, in order to get to the moon, we need a fuel that has this amount of energy in it.
Impossible.
They would not be able to fathom that. And you pack all the energy into this tube, and then you can reach, they would say, what's wrong with you? Yeah. Okay, so that's what gives me hope, that you can make a wormhole we'll go right to you when we have the material. Yeah. And then that would completely transform transportation in the world. In Star Trek, you wouldn't need the transporter. You just open a wormhole and step down to the planet.
Much less terrifying than having all your atoms reassembled.
Of course, exactly.
Is that doable at some point, you think?
Transporters?
Yeah, to break down your molecules and put them back together?
It's actually been done, technically. They have teleported a molecule from one place to another.
I mean,
a molecule.
Taking the energy that it became.
All of its facts.
And put it over here.
Tossed them over there.
Yeah.
Yeah.
Okay.
And it appeared exactly as it was before.
Now we have a lot of facts about us. It's a lot more information
than just the existence of the
molecule. I know you two do. You got a lot of issues inside.
Well, so just again to close this out and land this plane, this rocket. So I look forward to a future, because that's the whole spirit of the book, where the next wave of what happens is beyond the reach of what we can even imagine building today. That's the beyond infinity part.
See, but this argues against your thing in all seriousness about sort of the ego thinking we're at the center of the universe. So when you were talking about sort of how they found a way to invent fuel to go to the moon, it was egoless. It was actually the opposite. It was like striving to find other life, right? So it works against that argument, doesn't it, on some level, about that we're ego-driven?
Wait, you're saying we are not ego-driven because of the example of the moon?
I never said we were ego-driven.
But I think the example of the moon is very ego-driven because it was very fueled by the Cold War. When the Soviets put Yuri Gagarin in space for the first time, Americans panicked. And they said, the
translation,
phrase,
we lost our shit.
We lost our shit. And that's when when JFK came out and said, hey, space exploration is for all mankind. It was very ego-driven in that sense. So, I mean, we are what we are. We're a product of evolution, and maybe the ego was important in our survival, and here we are.
Or the fact that we can't be contained in a box.
Which is also important for our survival.
Indeed it is.
I've always said that about Neil. You can control him, but you can't contain him. I don't know.
Let that be the last words of this recording of StarTalk. Join me in thanking Janna and our comedian, Paul.